I'm about to embark on another exciting project here. If you don't know what this is a Hossfeld type bender, Hossfeld number 2 type bender. Very versatile bender, can do a range of different types of bends and different types of material. Now, this old Tony, he does a YouTube video on benders, and he built his own Hossfeld type bender. So that video is mostly on the bender and all the accessories that go with it. So if you want to learn a little bit more about it and how versatile they are, how useful they are, have a look at this old Tony. Look at that video that he's done. There are plans on the internet for a Hossfeld type bender, and it's not hard to find them. So if you do a search, you should be able to come across the plans. This is sort of just a basic model here, but it comprises of a fixed main frame and a swinging arm, and you would adjust these pins here to fit your metal, and then you would use the swinging arm to bend and form the metal. So I plan to build it per spec, although the plans you get off the internet are imperial, and of course here in New Zealand we work in metric, so there are some issues with conversion and things like that. But I have to say a shout out to Mark Presling, aka Prezzo. He has a YouTube channel, and I saw him using a Hossfeld type bender in one of his videos to do with his propane tank furnace. So I contacted Mark, and Mark had provided me with a lot of information about the bender that he built. So a big shout out to you, Mark. Thanks for all that information. That would certainly help me with my build, and having it in metric is just so much easier to work with. So as I said, I was going to build it per spec. The only issue that I have is these fixed frame and the movable frame, these big bars here. The specifications for the dimensions are 1/2 inch thick by 2.5 inches wide. Now, I couldn't get any steel with those dimensions, so I had to settle for the next size up, which was 2.5 inch or 65 millimeters wide, and it was 16 millimeters thick instead of the 1/2 inch. So 16 millimeters is about 5/8. I don't think it's going to be much of an issue. I'll just make it so that the distance from this inside to the inside here is the same as the specifications. So the thickness here and here will be higher, which will push the distance between the top or fixed frame out further. So things like the blocks, any blocks that fit into the fixed frame, or any accessories that fit in here, will need to be a little bit longer than the specifications. So not much I could do about that. The benefit is it will be stronger, which will be good, and disadvantage of that is I have to work this stuff out with any accessories that I make, and also it's probably going to be a lot heavier than just the standard bender if you use the standard specifications. So I'm going to start with the swinging arm frame. So I need to pull out the big heavy steel for that and mark it off and cut it to length. I've got the 2 pieces cut for the swinging arm. So the next step is there's a series of holes that need to be drilled down these bars here. And these bars, it's a mirror, so they're both exactly the same. So what I was going to do is I'll just weld maybe one to the other. Just put some tack welds in there and then I can put it into the mill and go through and find the center using the center finder in the mill. And then it's just a matter of the calculations of how far apart these holes are, and there's different size holes as well. So to get the bend that we need in here, I mean, this is, you know, 16 millimeters thick. It's 5/8 of an inch, and it's 65 millimeters or 2.5 inch, you know, across. It's kind of a big piece of steel, and apart from my foundry burner, I don't really have anything else that's going to be able to deal with this. I have a you know, hydraulic press, but it's going to need to be heated, and I don't think I'm going to get those bends in there. So what I plan to do is, wherever we need to bend it, plan to cut a groove in the steel, and then I'll be able to bend it on that line there, you know, not right through, but bend it on that line. That'll bend it down that way, and then I need to do the opposite up this way here. So cut not all the way through, and then I'll be able to bend it back on that line there, and that'll give us our kink that we need. Then I'll weld up the valley for both of these cuts, and hopefully we don't get too much distortion with that. So I think that's the easiest way I can do it with the equipment that I have. Anyway, I'll get these holes drilled in here, and we'll talk about how we're going to bend it a little bit later on. So I've got the work all set up in the mill here. I've got the end cutter here to face the ends here. I've put a little machinist jack under here, nothing to hold that down. We're quite close to the edge of the vise here. But down the far end I have another machinist jack underneath, and I've put a strap clamp there because we're further away from the vise and we've got a lot of overhang at the back here. So I think we're pretty good to go ahead and machine off this face here. Okay, so I've found the center across here, and I've locked up the gib on the y-axis. I've gone back to the front and found my X position. Now this is a 10mm wide edge finder, so I've come in an extra 5mm, so it's directly across, or directly over the edge of the steel here. So I can just move the X carriage down to where I need to do these holes. So before I do that, I just want to go off and check the plans again. I've done the layout on the steel bars. I've just put lines in the center where the holes should be. Now these aren't measured out properly, they're just sort of roughly done with a tape measure. But you know, if I'm drilling a hole and it's very close to that line, I'm probably in the right place. If I'm half an inch off, then something's definitely wrong. Put the size of the holes down the bottom here, and I've put up the top the distance from the front edge as we go down here. So you know, going by the DRO, it should be okay by just dialing the right coordinates there. That is almost 24mm hole there, and I'm just wondering whether I leave it at that and just turn the 25mm bar down to this size, or if I hunt around trying to find a 25mm drill bit, which will probably cost me the earth. I'll have a think about that, and we'll come back to that one, I think. Okay, so now we're on a series of 20mm holes. So these are the adjustments that you have in the bender. So the swinging arm has these 20mm holes, and the fixed arm also has them. I won't record everything here because it's just pretty much the same as what we did to the first hole, although we'll stop at 20mm, go all the way through, and then I'll finish off on this last one down the back here, which is 16mm. Then there is some holes down the other end, but we'll deal with that later. We'll get all this stuff done first. Okay, I've done the other end. I've just flipped it round and then supported it all again so that I can do this end. So I've got to just clean up the face here and put 2 holes up this end, 16mm holes. I've got a couple of clamps actually on here. You might have heard on one of the videos there's a bit of a crack, and it was the weld had broken. Those all the holes done. Now I just have a big mess to clean up. Yesterday I got the holes drilled in the swinging arm for the bender. As you saw, I tacked these together and drilled the holes and then taken them apart, and I've just sort of cleaned up the edges there. Everything went pretty good apart from the top hole here, which as I mentioned, I'd only had a 24mm drill, or just under 24mm. So it's a millimetre smaller than, you know, what the specification is. So still a little bit undecided what to do with that. I can always come back and drill it out another millimetre if I find a 25mm drill bit. But to be honest, I think 24mm will probably be strong enough. So the next step is to then mark out where this bend's going to go. And given that this is 16mm thick, and I think people, even with the 1/2 inch or 12mm thick steel, have issues bending it, I think I'm going to make a cut and just bend it along those cuts, maybe with the hydraulic press, so that I get a nice straight bend, and then I have some control over it. The other option, of course, is to heat it and bend it. Now, one, I really don't have anything to heat it up with apart from my foundry burner, and I think that's going to be a bit of a struggle. And the other thing is you have to sort of set up how you're going to bend it in the vise or in the hydraulic press or whichever, and those heated bends, you know, you've got to account for some, I guess, you know, curve of the bend and all that as well, so it might throw the measurements off a bit. So I think the easiest option here is to put a cut in there and to bend it, and then put a cut in the other side and to bend it back, and just so that you have them both sort of parallel. And that's going to be easier to control than dealing with something that is heated and then trying to work with it really quickly before it cools down. I've bent the arms and they came up pretty good. So the first one I had to play around and just try and get these angles the same, and then once I had that angle, I was able to set up the protractor here and make the second one, as you saw on the video, quite quickly. So if I lay them on top of each other like this, they just line up dead nuts straight. So absolutely happy with that result. Hydraulic pressed did pretty well. Haven't used this very much after I made it, but absolutely handy today. So I think the next step here will be to maybe make up a spacer for here, here and here, and then I'm going to weld these grooves up now where I've cut them and bent them out. Saw me cutting up a few bits of steel and polishing some bars up on the lathe. So we're ready to weld this together, and what I've done is I've made some pins to go through some of the holes just to keep everything aligned. They're nice snug fit pins, and then I've got spacers that go in here, and then we can clamp it together. The plan, I think on the internet, it has about 28 or 29 millimeter gap in here, but the plan I got from Mark was only 20 mil, and for me I think that makes sense because the bar that comes out of here for the handle to pull the bend around, I can use a couple of bits of 10 millimeter steel for that, which I have. So I'm going to do the same as what Mark had in his one, and use 2 bits of 10 millimeter steel. I think will work well for this design. So I want to give myself a bit of room in here to weld, so instead of having this at 20 millimeter apart and not being able to get the welder down there, I'm going to clamp it further apart, but to make sure that I've got the same shape, whatever distance I have in here that's over 20 millimeters, I need to put the same amount over here, which is over the distance, which I think is around about 117 millimeters, I think it's supposed to be. So when this is at 20 millimeters, that's 117 millimeters. So if I space this out, then I need to space, I need to make sure this is the same spacing over here. So I had this piece of 75 millimeter square stock or square tubing, and I was going to put that in there and then clamp that together, and then what that means is I need to go 55 millimeters on top of the 117 here, which is 172 millimeters. So I've made up a couple of packs for over here. Let me just put in the rods first. So these are quite a good fit, so it means it's going to keep the alignment from turning into a parallelogram. Then I've got 2 pieces that fit in here, and I have these spacers which work out to the right distance. We can clamp that, and I do the same for up the end here. And just make sure it's all flat on the table, and I think we're pretty good, so that's probably exactly the right position we need it. Then I'm going to weld these channels up here. I was talking to Mark about this, about did he get any distortion or anything like that. He said he had it all clamped and there was no distortion that he can remember. So I've pulled apart the jig for clamping all this together, and I think everything is still pretty good. What I'll do is I'll grind these welds up and flatten off the ends here, and then I'll put it back together with the pins, you know, where it's going to be in the normal position for when it's assembled. And I'll check it for alignment and flatness to see if we're all on target still. I cleaned up the welds here, and this has actually come out very, very good. So very happy with that. Put a lot of weld in here, a lot of penetration, so I think it's going to be strong enough. The good thing, it's absolutely flat. The pins are all kind of free. This one here is a little bit tight, but the main thing is that the arms here are parallel. So the next step is there's a handle that comes out of here, and it's kind of like a flattened round tube that fits in between here, and then you can put a handle, something a little bit like a big piece of steel like this, inside it. So I don't really have any tube to do that with, and so what I was going to do was use some of this. This is 60 millimeters by 10 millimeter thick, and you know, cut off two pieces, say that long or so, and they will fit in here next to each other, because this is 20 millimeter gap in here. So there will be two pieces. The bolts that bolt this together will go right through everything, and then it'll stick out the end here so long, and then what I'll do later on, I'll work out how I'm going to maybe squash up an end of a pipe and fit it on the end, or something else, just to you know, have some sort of bar where I can have a lot more leverage. So I think that's the easiest way to move forward from here, is just putting in some of this thick steel instead of trying to bend up you know, or squash down a bit of pipe, and I really don't have any suitable pipe for it. Looking at the plan, the big bar, that, you know, leverage bar that goes on the end here, the piece that slides on here is just over 200 millimeters long, you know, just over 8 inches long. So I think what I'll do is I'll have 200 millimeters out the end here, and we'll have to go just past this bar here, which will be actually a bolt once we bolt it all together. So let's have a look at that. That comes to about 400 long. So two pieces at 400 long is what I'll cut off for here. So that's going to go down the center there. I will weld these together to lock them together, and then in the mill I will measure out where these holes are using the DRO, and that will get me exactly in the right place, so the bolts will go right through without any issues. Also, I've made this bar here. This is a 32 millimeter round stock, and this is going to be the piece that goes in here. It's kind of a spacer type thing. So the options here were to either put a spacer in here and a bolt through everything, or in this case I've got the stock here to like turn down the ends here and then put a that's a 16 millimeter hole, or around 5/8 thread on the end here, and then I'll be able to put that in here, close it together, bolt this handle up, and then bolt this up here, and that will be absolutely solid then. I've got the swinging arm complete now, so it's come up pretty good, I think. So I cut off a couple of pieces, the 10mm flat plate, welded it together, drilled the holes out, and I've got a hole here for the sleeve that goes over the top. We can bolt it in or put a pin in there to stop it sliding off. Also turned up a spacer in here and threaded the ends here, so when you assemble it you put the spacer in first and then you bolt it all up. I've measured the distance here at the front and at the back here, and it's parallel, and the measurement is actually, well, I've got two sets of plans. One of them says 117 millimeters, and one of them says 114 millimeters, so it's 114 millimeters, so I guess it's maybe half right. But anyway, when you're building these things, you know, you need to build them to what you have and what tools you have. So although it might not be exactly the same, it will work just as well, I think. For example, in here, you know, this called for, I think, about 30 millimeter gap in here on the plan that was on the internet. However, the steel that I had, the double thickness, was 20 millimeters, so that's what I used there. So now I have to do the whole thing again, but for the fixed frame, which will go on the outside of here, so it's a little bit wider. But I think it's basically the same. There's a few different, different number of holes, and I think some other sizes as well. So a couple of changes there, but pretty much all the machining and bending and all that sort of stuff will all be the same. So here we are again in the mill. So this is the fixed frame, and I'm going to do what I did last time and draw on the measurements. So I've got the plans and I've worked out and drawn a little diagram here of where the, you know, how many holes and where they are, distances between the holes, and the commutative distance, you know, from the beginning here. So this is the one that I'm going to use for the DRO, so I know exactly where to stop on. There's different size holes. There's a couple of threaded holes, so I need to drill those a little bit smaller. A couple of M12 threads in here, so they need like a 10 millimeter drill bit and nothing bigger. So I just have to be careful not to do some sort of bonehead mistake and drill these little ones out bigger than what they should be. So I'll go ahead and transfer these numbers onto here, and that helps me when I go to drill a hole. I should be, you know, it won't be exactly on the line because I'm just sort of marking it out roughly, but it'll be very close to it, and that'll give me confidence that I've got it in the right place. Woohoo! I've drilled all the holes. They all appear to be in the right place and all the right sizes, so that's really, really good. So the next step here is to split these apart. These are only sort of being tacked together. I'll cut these off. We'll take this apart. I've put a little chamfer on the holes here, so I'll do that on the other side of each piece. And then the next part is to work out where we're going to put the lines here for the bending and how we're going to bend it to match the swinging arm that we have, because remember the material here is, well, each piece of material is 4 millimeters wider than
what the plan says. So the fixed frame will need to be a little bit wider to accommodate that.
I'm getting a lot of spring, so I'm getting this to the right angle, but I'm getting a lot of spring back when I release it. So I'm a little bit hesitant to go over, you know, it stays there and I can't get it back. I mean, I've got a big hammer, I could flatten it out on the bench, so maybe that's the approach. I'll go a little bit over and we'll see where we get to with that. I had to do a bit more tweaking on here. I think I was still having that issue where the, you know, there's a bit of spring in the steel and it was sort of contracting back in. So I've done that now and I've got the swinging arm inside the fixed arm. I think that is all good. What I'll do is there's a little bit of play there, which I think is good. You're going to need that. So I'm going to work out what that measurement is. I know it's parallel, which is fantastic. And I will put some packers in here and then clamp it up, and then we'll weld up the where the bends are, and it should hopefully not distort and be just like this once it cools down. It's all clamped up and ready to weld. I've measured the distance here again and it's all parallel and bang on the measurement we need. So I realised that the way I had it clamped it up before didn't give me much room to get into these welds down here. So I've done what I did on the swinging arm and I've just expanded it out another 55 millimeters, so 55 millimeters parallel. And because this frame is a little bit wider than the swinging frame, my big orange clamps were not long enough to go across here. So I had to use these ginormous oversized F-clamp to clamp everything together. But everything is nice and flat, and I'm going to put it in the vise and start welding it up. I cleaned up the fixed arm with the grinder and that came up equally as good as the swinging arm. So pretty happy with those results there. Now I didn't show it on video because it's just more or less the same as what we've been seeing for the swinging arm. So I had a little bit of an alignment issue. When it's parallel here, if I clamp these together and make it parallel here, the gap in here, the 20 millimeter gap here, needs to be shimmed out. So it needs a 2 millimeter shim here and a 3 millimeter shim here. And in fact, that will give us an extra millimeter clearance at the front here. So this is the important part. We want this parallel here. So if I have to shim these and make this block a little bit wider here and a narrower block at the back, that's absolutely fine. So I'm going to make some blocks to go in here next. And I'm heading down to the hardware tonight to get some bolts because I've run out of bolts. I've just got these 16mm bits of round stock in here to line them all up. And once I bolt it together, then that's pretty much it for the fixed frame and the swinging frame. Of course, I need to have some table mounts. There's 2 blocks that go here for the table. But this video is getting long enough, so I think we'll cut it and then we'll move on to part 2, where we can make up the mount blocks to mount it to a bench and the different pins that go in for your bending and that sort of stuff. You saw me cleaning up the square spacer plates on the grinder. What I did is I welded them together into a bigger blocks, and these are the blocks in here. So I got the fixed frame and the swinging arm frame pretty much all done. Just ignore this piece here. This is just a makeshift spacer just so I can clamp it so it doesn't tip over on the bench here. I've chamfered all the edges here as well, just like I did on the swinging arm frame, and it fits in very nicely. So if I bring it straight out here, I get about just over 1 millimeter on the end of the handle. So it all works pretty good, and the idea is you'd have pins that you put in here. And there's dies and blocks and things that you put on here, and on that side as well. That's the center pin. I don't know if that will be the pin that we would use. I think the pins may need to be hardened, so need to do a little bit more research on that. But anyway, the next video I will be making an oscillating block that fits in here, and we'll make up the square blocks that fit on these pins for bending. Maybe a bending eye dog. I can't remember what it's called. I'll probably put it on the screen. But it's for bending your smaller diameters, 6, 8, 10 mil round stock, and that gets done on the top here. I think this video's gone on long enough. We'll stop it here, and this is part 1, so in part 2 come and join us and we'll carry on making the accessories for the Hossfeld type bender. Thanks for watching.